Students, let us discuss about work done by a single force or cluster of forces. Now let us see work done by single force. Yes, as you are aware of the definition of work done by the what force, it gives the dot product of a distance into force. Let us see. This is the force F. This is a force F acting at a point A. When a force F is acting at a point A, if it displaces to the point B, then F bar dot AB bar is known as work done by the single force. Let F bar be a force and A comma B are the 2 points. When the force F is acting at a point A, when the particle A is displaced to the point B, then the dot product of F bar dot AB bar, then the dot product of F bar and what AB bar gives the what work done by the what force. If I take the what cluster of forces, so therefore if I take this one as this is one force, another force, this is say for example, if you can go for what like this, let it be any number of forces may act. Now you take this is F1, you take this is F2, you take this is F3, you take this is F4, this is nothing but what Fn. This is all the forces are acting at a point A, then the sum of all the forces, the net resultant force will be formed at a point A. When the particle is at a point A, when all the forces are acting at a point A, then the particle is displaced to the point B, means it displaces to the point B. Then work done by the cluster of forces means one or more forces. If it is only one force, I can take F bar dot AB bar. When you have one or more forces, then I can write work done by the forces is W is equal to F1 plus F1 bar dot F2 bar plus F3 bar and so on Fn bar. Sum of all the forces, it means net resultant force will be formed. Dot product of AB bar is given by work done by the forces, that is F1, F2, F3 and so on Fn, when they are acting at a point A. If we take the what dot product of sum of all the forces into distance, that gives a what work distance, that is work done by the what forces, right. Let us see the definition. Let F be the force, F bar be the force is a vector quantity, F bar be the force acting at a point A, then the particle displaces to the point B, then work done by the forces force is W. Therefore, W is equal to F bar dot AB bar. F bar dot AB bar. So when you have more than one force, you can add up. That gives the what? Work done by the forces. Let us recall the concept in detail by giving some examples, suitable examples on this. Now if I take, say for example, if I take, this is the force, this is F bar. F bar is equal to I plus 2j plus 2k, right? I plus 2j plus 2k. When it is acting at a point 1, 5, 4, and it displaces to the point 5, 4, minus 3, then work done by the forces. Therefore, I can write, first you find out AB bar. What is AB bar? OB minus OA. Therefore, AB bar is equal to OB minus 5 minus 1, 4. Next, 4 minus 5 minus 1. Minus 3, this is minus 7, correct? Now, you can take work done by the force is equal to F bar dot AB bar. This is equal to F bar, that is I plus 2j plus 2k dot of AB bar. Yes, come on, 4i minus j minus 7k. Take the dot product. So therefore, work done by the forces is I dot I is equal to 1, I dot j is equal to 0, I dot k is equal to 0. So therefore, similarly for others, I dot I 4. This is what? Come on, minus 2. This is minus 14. So therefore, this is minus is equal to what? Minus 12. It cannot be negative. You can take it as what? 12 x. So therefore, this is the work done by a single force acting at a point P when the particle displaces from the point A to the what? Point B. Yes. Once again, recall the what concepts of this for one or more forces. Let us see. If I go for, yes, 3 forces, I select, this is F1 bar, this is F2 bar, this is F3 bar, acting at a point A and B. I take one example which supports extensively. Let F1 bar is equal to I minus 2j plus 4k. Next, F1 bar. F2 bar is equal to 2i plus 2j minus k. Then F3 bar is equal to, yes, come on, 3i minus 4k. This is 1. So, be the three forces acting at a point A of 0, minus 1, minus 2, and the particle displaces to the point B of 3, 4, 1. Then the work done by the forces. Work done by the forces is dash. Work done by the forces is dash. Let us see. Now if I take this one as the solution of this one is very simple. What is this? This is minus 1, minus 2. B of 3, 4, what? 1, right? 3, 4, 1. So, coming this one is, first you find out AB bar. What is AB bar? OB minus OA. OB minus OA. What is OB minus OA? That is 3 minus 0. It's a 3i. Next 4 minus 5j. It's the next what? 3k. This is AB bar is 3i plus 5j plus 3k. Then F1 plus F2. Let us see F1 bar plus F2 bar plus F3 bar. Come on, add up all this. Now I minus 2j plus 4k plus 2i plus 2j minus k. Next 3i minus 4k, right? 3i minus 4k. Now this is add up I, 2i, 3i, 6i minus 2j plus 2j 0. Now next 4k minus 4k. Now this next this get cancels, minus 6k. This is nothing but F1 bar, this is F2 bar, this is F3 bar. This is called sum of all the three forces. Sum of all the three forces. So therefore, work done by the three forces is nothing but F1 bar plus F2 bar plus F3 bar, right? F1 bar plus F2 bar plus F3 bar dot AB bar. Yes, come on. Write down the what? F1 plus F2 plus F3 dot of AB bar. What is AB bar? This is nothing but 3i plus 5j plus 3k, correct? Therefore, now this is nothing but 18 that is plus 0 minus 3. So therefore, this is nothing but now work done by the forces. You may measure in terms of either works or what joules as you please. So therefore, this is the what? Work done by the what? Three forces. Once again, recalling the concept of work done by forces, for other example, it's a little difference. What is that? These are the three forces. Three forces whose magnitudes are not given. Whose magnitudes are not given. Only forces are given. Now, I change a little. When three forces are given with the respective magnitudes, in that case, work done by the three forces is dash. Now let us recall the what? Concept of work done by the forces. For another example, what is that? The example is three forces whose magnitudes three forces whose magnitudes are 3, 4, 5, which act in the directions of a act in the directions of 2i plus 2j plus k minus I plus 2j minus 2k. Next 2i minus j plus 2k. Acting at a point A of 4, 5, 4 and the particle get displaces to the point B of 0 comma minus 1 comma 1. Then the work done by the forces. Right, students, let us observe the difference between this example and the previous example. In the previous example, we come across about 3 forces without giving the magnitudes. But here you are given with what? Magnitudes. So therefore, now I want to find out the resultant force, sum of all the forces which is acting at a point A with the magnitudes. What I do is, the solution of this one is, I start. The work done by the 3 forces is nothing but capital F bar dot AB bar. But what is F bar? F bar is nothing but 3 into F1 cap, because he has given the magnitude of this force. Therefore, whenever the magnitude is given, but its magnitude is what? 3, but he has given some magnitudes. As we come across already in the vector algebra, whenever you want a vector of length lambda, you have to multiply that lambda into what? Unit vector. Therefore, 3 into F1 cap, 4 into what? F2 cap, plus 5 into what? F3 cap, right. 3 into F1 cap, plus 4 into F2 cap, plus 5 into what? F3 cap. Now you substitute those values. 3 into, yes, come on, 2i plus 2j plus k, whole divided by square root of 4 plus 4 plus 1 plus 1. Next, plus 4 into, yes, come on, 4 into minus I plus 2j minus 2k by square root of 9. Next, plus 5 into, yes, come on, 2i minus j plus 2k by square root of what? 9. This is nothing but, you can very well observe, this also 9, this also 9, 9. Square root of 9 is what? 3. So therefore, now I can write 1 by 3 into 3, 3, 3. Now you multiply 6i plus 6j plus 3k minus 4i plus 8j minus 8k, 10i minus 5j, 10k, right? Now you add up. So what you are going to get? Now this is equal to 1 by 3 into 6 minus 4i, 2i plus 10, 12i. Next, 6j minus 5j, 1j, this is 9j. 3k minus 8k, that is 13 minus 5, it's a 5k. This is nothing but what? F bar. So therefore, now let us find out AB bar. What is AB bar? OB minus OA. What is AB bar? OB minus OA. So therefore, I can write OB minus OA is, what is, come on, this point is given to be OA, that is OB bar. OB bar is equal to minus j plus k. Next, minus OA bar, minus 4i, minus 5j, minus 4k. AB bar is equal to, yes, come on, minus 4i, next to minus 6j, minus 3k, correct? Minus 3k. This is AB bar. Work done by the forces. Yes, come on. I can write this one as F bar dot AB bar. F bar dot AB bar. So therefore, already we have found out F. What is F here? F is equal to 1 by 3 into 12i plus 9j 9j plus 5k dot of minus 4i minus 6j minus 3k. So therefore I can write, take the dot product. So therefore this becomes minus 4i. Now this is minus 4i. Now 1 by 3 into minus 48. Now this is I dot I is what? 1. Next, now 9 into this one is minus, yes, now look here, 54 minus 15. Simplify, yes, 12 into minus 4, 48, 9 into 6, minus 56. Next, this is what? Minus 15. Add up 1 by 3 into, yes, come on, this becomes 54. So this is 52. Yes, 52, that is 50. How much it is? 102. 17. So therefore, minus, that is 117, right? 117, I think so. So therefore, this is nothing but 117 by 3. So it cannot be negative. So therefore, this is the work done by the what? 3 forces whose magnitudes are given, or else 3 forces whose magnitudes are what? 3, 4, 5, 6, which act in the directions. Direction is what? Vector. Vector means always vector represents what? Common force. Force is nothing but what? Vector quantity. I mean, nevertheless, the forces are representing through the what? Vectors. The 3 forces whose magnitudes are 3, 4, 5, which act in the directions of what? Yeah, that is this. And acting at a point what? A, and the particle get displaces to the what? Point B, then the work done by the forces. Since look here, magnitudes are given, here forces are not given directly, magnitudes are given, hence for finding the magnitudes, first you have to find out F bar. So because all the 3 forces whose magnitudes act at a point, here sum of all the 3 forces, the resultant force will be formed at A, then the particle get displaces up to the what? B. So therefore now I can take this is, now F bar dot AB bar, find out F bar, 3 into F1 cap, 4 into F2 cap, 5 into F3 cap. So therefore substitute the values, simplify, we got it F bar, and AB bar means what? Come on, distance. Now OB minus OA, now you got it, take the what? Dot product. That gives the work done by the what? 3 forces when 3 magnitudes are given. I mean, you see, the students, we come across the 3 situations. One is work done by the single force F bar dot AB. When the work, now second example is work done by the cluster forces. Cluster forces means what? 1 or more forces. In that case, sum of all the forces will be acting at that point. Then sum of the force dot or distance AB bar gives what? Work done by the forces. When 3 forces are given, then sum of the 3 forces will be formed what? Come on, is acting at a point A, then the particle gets displaced to the point B. Therefore F1 bar plus F2 bar plus F3 bar dot AB bar gives what? Come on, work done by the what? Forces. Work done by the forces. Okay. Now when the magnitudes are given, then we also find out the what? Work done by the 3 forces. Now let us have the applications of dot product on special problems. Let us see, in a cube, the angle between the diagonals of a 2 cube, or angle between the diagonals, that is angle between the 2 diagonals of a cube. So now if I go to this one is, oh, okay, if I take X, if I take Y, if I take Z, C, A, it's a what? B, it's a C. x. Now this is nothing but d. Next, z. Okay, this is nothing but e. Right. Now coming this one is, this is one diagonal. Let me write the special problems are the angle between any two diagonals of a cube. Now I take one diagonal is AE, other diagonal is what? OZ. Since cube is a what? Three-dimensional 3D figure, it's very difficult to show the what? AZ with clarity. You have to assume the perception left to the student. So therefore, now let us take OA bar is equal to I, OB bar is equal to Z, OC bar is equal to what? K. This is one diagonal, this is another diagonal, right? Now I start. The solution of this one is very simple. In a cube, A, B, C, D, E, F. Okay? E instead of F, you take Z. In a cube A, B, C, D, E, Z, let O be the origin, comma, OA bar is equal to I, OB bar is equal to Z, OC bar is equal to C. Okay. They can be taken as X and Y as well as Z axis. No problem in that. Represents the edges of a cube. Now the diagonals are first of all OZ. So therefore now I can write OZ is equal to OD bar plus GD bar, that is a DC bar. OD bar plus DC bar. DC bar. Okay. So if you want, you can take this one as what? F also. What is there? Yes, now. So coming this one is A, B, C, D, E, F, G. Okay. E, F, Z. Now coming this one is this side, edge. This edge is parallel to Z axis, means parallel to K. This is also parallel to K. This is also parallel to K. So therefore, equal and like vectors. These two are parallel, equal and like vectors. These two are parallel, equal and like vectors. So therefore, now what I do is, now DC bar, this is OD bar, right? OD bar is the diagonal of a face. What's a face? OADB is one face. OF bar is the diagonal of another face. OAFC is another face. Still many diagonals of a faces are there, but they are not convincing to observe because of three-dimensional approach. So better confine to what? This and these two are the what? Diagonals of a face. So therefore, now I can write this one as OG bar is equal to OD bar plus DC bar. So therefore, now I can write OD bar. What is OD bar? OD bar is nothing but, look here, OD bar is nothing but OA bar plus AD bar. Yes, therefore, OD bar is equal to, this is nothing but I, that is AD bar. AD bar and OB bar are parallel. This is nothing but Z, correct? OD bar is equal to I plus J. So therefore, with this one, similarly, I go for what? That is OF bar. What is OF bar? OA bar plus AF bar. So therefore, OF bar, OA bar I, AF bar is parallel to K. I can write what? OC bar is nothing but OF bar is nothing but I plus K. Followed. Next, what I do is, that is OC, DC bar. The DC bar is nothing but, look here. Now OD bar. What is OD bar? I plus J. What is DC bar? DC bar is nothing but OC bar because they are parallel and equal. So therefore, I can write OC bar is equal to I plus J plus K is nothing but a diagonal of a cube. OC bar is a what? Diagonal of a cube. When it is diagonal of a cube, okay, diagonal of a cube, then the another diagonal is there, AE bar. Let us find out what is AE bar. OE minus OA. Yes, OE minus what? Come on, AE. So therefore, I want to find out instead of this OE bar. OE bar can be written as, look here, this OE bar can be written as OB bar plus BE bar I write minus I. How, sir? This OE bar by using vector addition, OB bar plus BE bar. Addition vector can be applied anywhere, anytime, whenever the terminal point of the first vector coincides with the initial point of the second vector. So therefore, now this is nothing but, what is OB bar? J. Now BE bar is parallel to K. Therefore, this is nothing but OC bar is nothing but K is nothing but I, correct? Is nothing but a I. So therefore, now I got it. AE bar is equal to J plus K minus I. Once again, look here, OC bar by using vector addition, OD bar plus DC bar. DC bar is parallel to OC bar. Therefore, I can write OD bar is nothing but I plus J. OF bar we proved by using this I plus J. OC bar is nothing but K. AE bar, we do not know exact what there from the what figure. So better write as what? Position vectors of its extremities. OE minus OA. What is OE? We don't know. OE is nothing but by using vector addition OB bar plus BE bar. So therefore, OB bar plus BE bar, OA bar, A bar. So therefore, J plus K minus I. Therefore, AE bar is equal to what? J plus K minus I. J plus K minus I. Okay, now I want to find out the angle between the two diagonals of a cube. So therefore, angle between, very first problem is the angle between the two diagonals of a cube, are A bar and OC bar. Therefore, cos theta is equal to A bar dot OC bar by OC bar, right? Yes, now we A bar modulus of A bar into OC bar. Take the dot product of AE and OC. What is AE? J plus K minus I dot I plus J plus K by root 3 by root 3. So therefore, take the dot product. This becomes J dot J 1, K dot K 1, I dot I minus 1 by 3. This and this get cancels in 1 by 3. So therefore, you can very well observe the angle between cos theta is equal to 1 by 3. So therefore, the angle between two diagonals of a cube is theta is equal to cos inverse of 1 by 3. Theta is equal to what? Cos inverse of 1 by 3. So now students, this gives the the proof of a special problem in dot product. The angle between any two diagonals of a cube. The two diagonals of a cube are OC bar and what? A bar. Right? So therefore, OC bar and A bar. Let us assume that now OA is along x-axis, OB along y-axis, OZ along what? OC along what? Z-axis. Always we represent x-axis with I. Means that is OA is equal to I, OB is equal to J, OC is equal to what? K. Therefore, A is equal to 1, 0, 0, B is equal to 0, 1, 0, C is equal to 0, 0, 1. Be three vectors representing the three edges of a cube. So if it is edges of a cube, in that case, now let us find out the diagonals OC bar and what? A bar. Before OC bar and AD bar. So therefore, now OD bar is equal to OA bar plus AD bar. Therefore, OA bar is I, AD bar is nothing but, AD bar is parallel to OB bar. So therefore, it's what? J. OF bar is equal to OA bar plus AF bar by using vector addition. Therefore, OF bar is equal to OA bar is equal to I. AF bar is parallel to what? OC bar, means parallel to K. Therefore, I plus K. Next, OC bar is equal to OD bar plus DC bar. Since the diagonals are OC bar and AE bar, I got it OD plus DC. So therefore, OD bar I plus J, as we have proved. DC bar is nothing but OC bar is nothing but I plus J plus K. Next, AE bar is nothing but OE minus OA. So therefore, OE is nothing but OB bar plus B bar by using term, that is vector addition. OA bar minus I, you substitute. Yes, we got it. Yes, two diagonals, that is face diagonals also, edges also. The angle between two diagonals of a cube are A bar, that is AE bar, OZ bar. Yes. Now OZ bar. Then cos theta is equal to AE bar dot OZ bar by modulus of AE bar into modulus of OZ bar. So therefore, substitute their vectors. Take the dot product by using what? Whenever A bar is equal to A1I plus A2J plus A3K, B bar is equal to B1I plus B2J plus B3K. What is A bar dot B bar without an angle? A1 B1 plus A2 B2 plus A3 B3. So therefore, A dot B, that is J into J, 1, next K into K, 1, minus I into I, that is minus 1. So therefore, by 3. So therefore, angle between two diagonals of a cube is what? Theta is equal to cos inverse of what? 1 by 3. Cos inverse of 1 by 3. Now, in this only, under this proof only, I go for another special problem. The second question is, under this proof, under this figure only, the angle between the diagonal of a cube and the diagonal of a face of a cube, diagonal of a face of a cube, the angle between diagonal of a cube and the what? Diagonal of a face of a cube. Let us see, the diagonal of a cube is what? OZ. Face diagonal is what? OD. If you want, you can take OF also, it makes no difference. So therefore, the proof of this one is very simple. That is, the diagonal of a cube is equal to OZ bar. What is OZ bar? It is I plus j plus k. Next, diagonal of a face of a cube, yes, cube is equal to OD bar. OD bar is nothing but you have here I plus j. So therefore cos theta is equal to OZ bar dot OD bar modulus of OZ into modulus of OD bar. So therefore I can write OZ bar dot OD bar. What is OZ bar? I plus j plus k. I plus j by this is root 3 is nothing but root 2. Now I want to find out the angle between the what? Diagonal of a cube and face diagonal, OZ bar dot OD bar. Take the dot product. Cos theta is equal to I dot I 1, j dot a 1, next 0 by what? Root 3 into root 2, 2 by root 3 into root 2. This is nothing but 2 by 3. So therefore, the angle between diagonal of a cube and diagonal of a face is given by theta, that is theta is equal to cos inverse of square root of 2 by 3. Yes, students, we come across about the special that is examples by using the definition of our dot product, that to angle. First we found out the angle between any two diagonals of a cube. Any two diagonals means OZ bar and AZ bar. Next we went for the angle between diagonal of a cube, that is OZ bar, and the diagonal of a face of a cube, that is OD bar. Already we found out OD bar. We have found out what OZ bar. Apply the what? Cos theta OZ bar dot OD bar by modulus of OZ into modulus of OD. Apply, therefore the angle is what? Square root of 2 by 3. Yes, in the first one, angle between the diagonals of a cube is nothing but theta is equal to cos inverse of 1 by 3. Angle between the diagonal of a cube and the face diagonal is what? Theta is equal to cos inverse of square root of 2 by 3. Don't get confused. You must be very careful. You must aware of angle between the two diagonals, angle between a diagonal and a cube.